One of the things in life you can count on is gravity. The force of gravity is what makes people fall. As a result of falls, many workers are killed or injured. What's odd is that people are usually more careful in their private lives, wearing seatbelts when driving a car and helmets when on a motorcycle. We install safety devices in our homes to protect our families. We protect ourselves everywhere with security devices, except where it is needed the most, in the workplace.
When we talk about fall protection systems, we need to understand that we're talking about basically two different avenues. We either have fall prevention, preventing a fall before it ever occurs, or we have fall arrest, which means systems that we put into place to pull a worker up short and minimize the amount of injury that's done to them. So as we begin this module, what we need to do is focus on OSHA-approved fall protection systems. There are currently 6 of those systems. As you see listed below, guardrail systems, safety net systems, warning line systems, safety monitoring systems, personal fall protection systems, and work positioning systems are the ones that OSHA has approved. Of these systems, individual companies do have the ability to limit which ones they will accept to protect or remove the liability from them in the event of an accident. So let's begin by going through the rest of this presentation. What you can see here is inside of a facility, you can see that there are temporary guardrail systems that are set up around an elevated work platform. Hanging from the ceilings, we see retractable lifelines that are then attached into the back of harnesses where workers are working close to openings so that in the event that they slipped or fell, it would limit their falls to less than 4 feet. So, personal fall protection. What constitutes personal fall protection systems as defined under OSHA? First of all, there are 3 things that make up a fall protection system. Number 1, it has to be a full-body Class 3 harness. In the old days, they used to wear a Class 1 body belt. The problem with the Class 1 body belt is that when a person got pulled up, it could either rake their back or cause severe internal damage. So in October of 1998, OSHA required the use of full-body harnesses. In addition to that full-body harness, they're required to use what's called a fall arrest lanyard. A fall arrest lanyard differs from a work positioning lanyard in the fact that it contains a deceleration device. The third part of this system is an anchor point that's capable of supporting up to 5,000 pounds or 2 times the intended load that will be placed on it. You can see the Class 3 full-body harness, straps going over the shoulders, around the waist, and around the leg straps. The back plate, located in the center of his back between, or what we refer to commonly as a dorsal ring, located between the 2 shoulder blades, is the focal point that when they fall and get pulled up short, directs the forces of the fall into the large muscles of the upper torso and the lower legs. These are the only muscles capable of withstanding that kind of impact. What I've attempted to do here with the calculation is to kind of give us an idea of the forces involved with a fall in one of these systems. The average worker is rated at 220 pounds. That's a worker plus his clothes plus his tools. If he falls the full length of an authorized lanyard, which is 6 feet, that means that upon initial impact, 3,970 pounds of force are developed. If the lanyard is installed as you see it here in this slide, with the deceleration device as close to the center of his back as possible, clipped into that dorsal D-ring, then he can expect to receive a 1/3 reduction in the force of that fall. So approximately 1,324 pounds of the 39 is then removed. Well, what happens if he hooks it up backwards? By that I mean we put the deceleration device against the anchor point and put the other hook into the center of his back. Will it still function? The answer to that question is yes, it will still function. But what it does is it degrades the system and reduces the efficiency of it and allows more force to be transferred to the individual as opposed to being absorbed. As we've equated to in this illustration, hooked up incorrectly, we can expect a 1/4 reduction in the force, or approximately 993 pounds. So now that worker's still going to get hit with about 2,800 pounds of force in the center of his chest. That equates to just about having the front end of an automobile picked up and dropped right straight down in the center of your chest. We've talked about the three elements that make up a personal fall arrest system. Let's talk about a safety monitor system. It's a little bit of a different beast. Safety monitor system, second system, in order to use, OSHA lays down requirements on when we can use this system. In order to use this system by itself, first of all, we have to be using it on what's called a low-sloped roof. That means that the pitch of that roof is less than 412. In most cases, your major industrial complexes have flat roofs, so that is a 1-1 pitch, which is less than 412. The second criteria is what they call the W policy, which means that they have to measure the width of the narrowest side of the geometric plane of operation, and it cannot exceed 50 feet. That can be easily accomplished with either drawings or by pulling a tape by anyone. The third requirement is the one that gets most people in trouble, and that's the term knowledgeable. If I asked everybody that viewed this CD what the word knowledgeable means, I'd have just as many definitions. But what we need to understand, what we think knowledgeable means and how OSHA defines knowledgeable are two different entities. OSHA defines a person as knowledgeable as someone who understands the task being performed. And because they understand the task being performed, they also understand the hazards of the task that they're performing. The example that I normally use in the class to illustrate this is an air conditioning mechanic, an HVAC mechanic. An HVAC mechanic deals with this stuff up on the roof. It's called Freon. Freon in and of itself is a gas, and it's not too bad, other than the fact that it does cause degradation of the ozone. And there are specific rules that say that before a technician can cut into one of those systems, he's got to pump all that gas out of there, leaving a very small residual amount. But once again, if that mechanic was not knowledgeable of those federal laws and he cut into that pipe, would he create a hazard? The answer is probably yes. The second part of that is in order to separate pipes on that air conditioning unit that have been pumped down, in most cases has to what we call unsweat them with a torch. And any time open flame comes in contact with that gas, it forms another gas called phosgene. Phosgene is a very deadly gas that's been used for extermination purposes in days gone by. So we start to understand that not understanding the hazards of your trade can set us up to have a major accident, thus the word knowledgeable. In this picture, what we're trying to show here is that a safety monitor system consists of worker bees and a person who's designated as a safety monitor. Safety monitors on roofs are usually set aside from worker bees, and they only have one responsibility: to make sure that all the worker bees do their work in a safe fashion. The safety monitor itself, he's in charge. It's his call. He's the man on scene. He's the most knowledgeable person on scene. The other guys are worker bees. A safety monitor system consists of a minimum of 2 individuals, a safety monitor and a worker bee. That's the minimum size. But now if a task on that roof is going to require someone to hand you a bundle of nails or some more shingles or to move parts to or fro, then you've got to have a second worker bee. OSHA does not say how many workers a safety monitor can monitor. He leaves that call up to the safety monitor himself, because after all, he's knowledgeable of the task, he's knowledgeable of the trade and the hazards associated with it. The next systems we want to talk about are safety net systems. Safety net systems are probably the most ineffective fall protection system that OSHA approved. And the rationale behind that is fairly simple. In order to use a safety net system, first of all, it's a very elaborate system like what you see down at Circus Olay or in circuses when you've got high workers that are working over the top of it. Should they fall, the net captures them and prevents them from being injured. But prior to installing a safety net system, first of all, a competent person engineer must inspect that. We refer to him as a qualified person. The qualified person has an engineering degree. He inspects to make sure it's capable of performing its design function, that anchor points are capable of withstanding the impacts of that fall hazard. In addition to that, he's required to perform what's called a drop test. A drop test means that he takes a gunny sack filled with 300 pounds of sand, chucks it out in the middle of the net, and as the net absorbs the impact, it doesn't strike anything down below. If it does, it doesn't pass inspection. Once it's installed, it becomes his responsibility or that of a competent person to re-inspect it each shift before a worker works over it. Now, as I said, it's the least effective means of fall protection. We still have them at the Space Center, but we use them for falling object protection, not personal fall protection. i.e., if a person falls into the net and lands and it absorbs the impact, the next action that happens to that worker is he is then catapulted back up into the air. And what makes it very ineffective is that there's no guarantee when he comes down the second time that he'll even land in the net. And so, for this reason, here at our Space Center, we do not authorize the use of safety net systems for anything other than falling objects. We require positive fall protection. As you can see on this slide, we've got a safety net system. We've got a worker who's out walking into the net system itself. It's protecting him from falling through. In this particular case, you can see that he has a safety line affixed off to an overhead anchor point in the red circle and then attached off to the back of his dorsal ring. So in this case, he's employing two separate systems. What you do not see is a deceleration device which would absorb any of the impact. So should that net give away, in this case, he's going to take a significant fall with no reduction in force. The fourth system that we want to talk about is called a warning line system. And as we say, it's the most common used system in most industrial workplaces. It can also be the most misused system if it's not set up correctly. What we're attempting to show you here is that they use a series of what we call stanchions, which are generally made out of PVC, or the newer ones that are made out of plastic and they're like cone structures, like the red one to the far right. Once they're set up 6 foot back from the edge, then they have to be weighted down. The distance between them is determined by connecting material, as we're going to talk about in a minute. The stanchions themselves are set back 6 foot from the edge of the roof. Because in most cases they're very light, there'll be a tendency for them to be blown off. So if they're blown off, they will do us no good, so we have to be able to weight them down. The way that they're weighted down is sandbags are filled with approximately 8 pounds of sand, and then 1 sandbag is placed on each of the pairs of legs, thus putting 16 pounds of weight holding down a stanchion 6 foot back from the edge of the roof. Then they're positioned all the way around the roof. The only difference for that are the newer ones that are made out of plastic. What they have is a black donut-looking structure that drops down over. It's made out of used tires. It also weighs 16 pounds. So it fulfills the same requirement. It's just easier to set up and a much more precise system. Looks better sitting on a roof. Once they're put into place, the only other requirement that we have is we have to connect it together. So how we connect it together is going to be predicated off the breaking strength of the material. Ideally, when these systems were designed, it was designed to be used with a 3/16 monofilament rope, that plastic like ski rope. Ideally here, it would not absorb moisture or would hold up better to the elements. Lightweight by nature, but yet it still had a breaking strength of over 500 pounds, which is the basic requirement. Other things that can be used, nylon rope, chain, cable, all these materials, as long as they have a breaking strength of at least 500 pounds, can be used. So where do people go wrong? In most cases, instead of positioning these stanchions all the way around a rooftop, they'll put one in each corner and take that yellow caution tape and tie it from corner to corner to corner to corner, which in and of itself doesn't seem too bad until the wind starts blowing and it starts to billow like a sail. Then there's nothing to prevent someone from walking off the roof. The idea here is that each stanchion is individually tied off, one from another. That way, should a person back in between or back into a stanchion and apply more than 16 pounds in a downward or outward fashion, the stanchion will fall over and warn him to stop.